Hello and welcome everyone to this eCognition Deconstructed video. Today we're gonna have a look at the majority vote feature. So first time we're not gonna look at an algorithm, we're gonna look at a feature. And what you need to use the majority vote feature is at least 2 image object levels and a classification on a sub-level. And then you can use either this majority vote area or majority vote count. You're gonna find those features under object features, relations to objects, sub-objects, and then majority vote area and majority vote count. And those features return the classification majority of a sub-level, either based on the number of image objects that are classified on a sub-level or the largest area of sub-objects. And we're gonna have a look at both in theory and also in an example. Let's imagine a fairly simple example where we do have one image object level classified into 2 different classes. So we do have forest and water, and then we have a super level with image objects that are unclassified. Now we can use the majority vote features to assign classes to those image objects on the super level based on the relation to the sub level. Let's have first a look at the majority vote area. That's very simple. So it's gonna return the class of the largest area of a sub level. And those are more or less the values. So the first object that you see on the top left here on the super level is gonna be classified as water, or has the feature, the majority vote area feature water. And then you simply can use this feature to classify those image objects, right? The next one, water, we do have 2 objects classified as water, sharing a 70% of the sub area of the superclass. And on the right hand side, we actually have a tie. And what it does, it returns a random class if there is a tie. And yeah, now let's have a look at the majority vote count. That counts the number of objects on a sublevel. So the first one will be classified or will have the feature value forest instead of water, because we have 3 sub-objects as forest. And even though water shares the largest area of the sublevel for this object, it still gets assigned to forest because we are looking at the count. And the second one is water, and the third one, water or forest. Again, it's gonna, if there's a tie, it's gonna pick randomly one of those classes. And now I'm simply gonna show you a project to illustrate how that works in an eCognition project and what you need to do in order to use the majority vote and how to use the information of the majority vote feature to classify image objects on a super level. And I'm also gonna show you how you can get those exact values for each object if you are interested in knowing that. So let's jump into eCognition and let's have a look at the project that I prepared. And I'm gonna walk you through that project, but you also can download it, so no worries. You also can get the whole rule set and the data that I'm showing you, and you can execute it yourself on your machine. If you have the data, there's a data folder and a project called majorityvote.dpr. dpr is the project file. And yeah, you simply can drag and drop that into developer, and then the project should open. And what you're gonna see is that we have an image object level already. That's our sub level, right? Where we have a classification. Let's have a look at that. We do, okay, first I'm gonna change the view here to set development layout. And move that to the side. Yeah, so we have different classes. We have water, urban, bare soil, grassland, and forest. And we want to use majority vote, this feature. And again, you need 2 image object levels in order to use the majority vote feature. Let's first have a look at where you're gonna find this majority vote feature. Here in the feature view on the right hand side, object features, relations to objects, sub-objects, and there you're gonna find majority vote area and majority vote count. We do have pre-created 1 each, and you see in the brackets the value of 1. That means that's a majority vote result, the majority vote area feature in this case, for the objects 1 level below. You also can create another one and increase the distance. If you set 2, it's gonna look 2 levels below. And you might have a project with 7 levels, and here you can adjust onto which level this feature should look. Okay, so that's where you're gonna find it. I cannot display it yet because I just have 1 level. And let's have a look at the rule set. First, prepare super level. What I'm doing here is actually I'm creating somehow a second image object level, and I apply a chessboard segmentation. So it's a generalization that I do. I first copied the existing image object level 1 above, so we have 2 levels. Then I actually remove the classification, merge the objects, and then I apply segmentation on the super level and create a chessboard. And now we have it. Let's display the outlines. I'm gonna highlight the super level in yellow. So you see we have created a chessboard. And that's simply our level majority vote. That's what I'm gonna use to display the feature and to classify objects using this majority vote feature. And on the sublevel, we still have the level classification. And yeah, now what we wanna do is classify the super level majority vote based on the information or the classification information of our level classification, so 1 level below. Let's have a look at the feature. So you can display the feature values of 1 feature across all image objects if you simply double click it here. Let's first go for the majority vote area, and we do not have to create that feature, right? It's already there. It's the one that's created by default 1 level below, so that's what it's looking at. So it's exactly what we need. If I double click it, the objects get colorized. Usually if you have a feature that displays values, they are colorized in a color scale of black to white, so grayscale. But now actually this feature returns class names, so it's difficult to colorize, right? But you see here, if I hover over it, it gives me the information of the object feature majority vote area. Okay, let's go here. Right, so that's what I display here. And forest, that's all forest. This one would be grassland. So this one is the result of the majority vote area for this specific object. Let's go up here where you should have water because, yeah, this area is water. And let's display the class color again, right? So these were water. We had some forest here and what was this here? Grassland or something. But currently it's just there as a feature. So how can you assign those objects to that class? You, for example, can define that information or that connection here in the class hierarchy itself for each class. You could define, for example, like the definition is here. I did that previously. If this feature majority vote area, so if the majority vote area returns bare soil, then this is bare soil, right? So if this is true, it's a class bare soil. And if you define that, so you can do it, you can find those class descriptions here in the class itself. Then to classify the image objects, you would need to use the classification algorithm. I'm going to show you that in a second. So that would be one approach. Another approach would be to simply use a assign class. And what I did here is I simply used the same condition actually. So I use a assign class and say, all right, if the majority vote area equals water, then put it into the class water. Let's execute this one, for example, and you see those objects up here where the majority of the sub-objects regarding the area is water are now classified as water. And then I did that for urban, for all the classes that I have, and execute this one. So those are the objects that the majority of sub-objects regarding the area is urban. Next one, that looks like forest, and then we have background, I guess, and majority, what is this? Yeah, grassland. So that would be the majority vote result if you use it for classification based on the area, right? Let's maybe split the view and display the initial segmentation or classification and segmentation at the bottom. And here we created a chessboard. You also could do a multi-resolution segmentation. You could do a hexagon segmentation as we show in the webinar. So check that out as well on our YouTube channel. Yeah, any sized object. So you can become very creative. And what I also wanted to show you, I'm gonna increase transparency here a bit. And side by side, right? Yeah, even though we do have actually a lot of urban here, it gets classified into the grassland class. Now, actually, I would be interested if that was a close call. It looks like actually all the three classes, forest, grassland, and urban, more or less share like 30% of the whole area of this one. You can have a look at another feature, which gives you the percentage, the relative area of a sub-object. I'm quickly going to show you where you find that, and that's actually the information that the majority vote feature is using, right? So that information here, the relative area, you can find that feature also in this section here, relations to objects, sub-objects, and then you have here the relative area of. And you can compute that also. You can define the distance, and you get a value between 0 and 1, 1 meaning 100% and 0, 0. And actually you see that bare soil here for this super object covers only 1% or 1.5%. Then we have forest 23%. And actually grassland is 48% and urban 27%. So grassland is the clear winner here, even though actually visually I would say it's... no. If you know the numbers, they're not objective anymore. Yeah, but you see grassland won this one, so we classified it into grassland. Let's check one more object, maybe this one, and you clearly see, that was a close call between forest and grassland. So forest 46% and grassland 43%, but forest won, that's why it got classified into forest. Maybe down here, one last example. Right, that's pretty clear. A lot of bare soil, and that's 70%, so it got classified using this feature, majority vote area, into that class. Now, the next section, I'm using exactly the same, but I'm using a different feature, but the conditions are the same. Instead of using the majority vote area, I'm using the majority vote count, and that counts how many objects are there. So, again, as the theoretical example that I showed you before, the area doesn't matter, right? Only the number of objects. So if we execute this one, actually classification changes drastically because it's looking at the number. It doesn't make that much sense here for this land cover classification, I would say. But in other cases, it makes a lot of sense. Let's say you have single trees detected on a sub-level, different tree types, and then you want to classify the district or a patch, a parcel, based on the count, so the highest number of trees in a for certain species or something like that. Right? So both can make sense. In this case, land cover classification, I think the majority vote area makes more sense. I also displayed here in the image object information already the number of, so that's also a feature that you're going to find in the relations to objects, sub-objects, and you have here the number of. And that gives you how many sub-objects of a certain class are covering my super object. And again, let's go here for this urban patch here. Area would be clearly water, right? But for the count, it's a different story. We have urban 13, so we have small buildings or stuff classified there. And that's why it gets classified as urban on the super level, our level majority vote. Okay, I'm using here assign class, but I also showed you that I defined something in the class description. And actually, to use the class description, you can use the algorithm classification. Classification looks into the class hierarchy, into the class definition itself. And yeah, you need to define the active classes, select all, and then erase all classification. Yes. All right. And that's gonna classify my objects based on the definition in here. And that definition should actually equal this section here, classify using majority vote area. So if I execute the classification, it should jump back to the previous results that we had before I executed the majority vote count. So let's try this. Yeah, that should be identical. So two different ways. You can go for any way you like. I'm gonna show you two more things. One is the chessboard segmentation that I've chosen here. I've chosen an object size of 150. Let's go for smaller one, 50. And then if you execute the first section again, actually I'm cleaning up everything here, so that should run smoothly if you change only the chessboard size. And let's display the outline. You see the chessboard that is created on the level majority vote is way smaller. Now I can classify it again, and it is not as generalized as the 150 size, so it actually looks a bit more like the map that we see below. But again, the object size and the object creation, that's up to you how you do it. You can again use multi-resolution segmentation, you can use a quad tree based segmentation, whatever you think makes sense or whatever you want to have. So last but not least, I'm gonna deactivate this chessboard segmentation in this upper section here where I prepare the super level. I'm gonna activate this little section here. So I simply want to show you that you also can do it based on districts, for example. Let's say you have a vector file and you want to compute or use the majority vote feature based on the polygon outlines of your vector. So the data is in the data folder. That's not an issue, so you simply can also use it as I do. And then after that section, you're gonna see we're gonna have a vector layer loaded automatically. It's this one. Those districts, actually, they are created by myself, so they don't make any sense. And what I did is I created image objects based on the vector outlines. And now I simply run the majority vote section again, but now it's gonna use the image objects that I created based on the vector, because it's simply using the level majority vote, and that's actually the representation of my vector outline. So execute this, and that's based on the area. So this one, majority vote winner is forest. Again, we can check the values that are underlying this majority vote, and forest is 40% for this area. In this case, forest is 56%. Here we have 54, and here we have 60. And down here, grassland wins because it's 41. Okay, and urban is always a small fraction of the total area. In this case, it's actually 20%. Coastal area here, urban 5%. Yeah. So again, the objects of the super level, it doesn't matter. You can use any objects you like. Good. So that's actually the end. I simply want to show you how to implement the majority vote into an eCognition project, into a rule set. Now you can go ahead, use it yourself. Yep, let us know what you think. Give us feedback, use the community, and thank you very much for watching. Here next time.